We start this section by first defining what the logarithmic function is. If you look at the exponential function that we had in last section, there were not any places in the graph where you could draw a horizontal line and intersect the graph more than once. So this means that exponential functions are one-to-one, and therefore they should have inverses. If we start to find the inverse like we did in section 2.7, we have the following. So exponential has the form y equals b to the x power. And if I try to find the inverse by first switching x and y, and now solve for y, we have no way to solve this for y. Okay, so the question is, how do we solve for y? Well, with our given information, there is no way. We need a new notation / function, which we call the logarithmic function, or simply log function for short. Okay, so we define the log function as if b to the y equals x, then y equals the log of x with base b. So its log is nothing more than the inverse of the exponential function. Every log function can be written as an exponential function, and every exponential function can be written as a log function. Our first two examples are going to emphasize this point, that every log can be written as an exponential and every exponential can be written as a log. Example 1, write each equation in its equivalent exponential form. So A, we have 2 equals the log of x with base 5. Okay, so to write as an exponential, the base of the log becomes the base of the exponential, and 2 switches sides, becomes the exponent on x, and x switches side, it becomes the equals part. So the exponential equation x equals 5 squared is the same thing as the log equation 2 equals the log of x with base 5. Part B, we have 3 equals the log of 64 with base b. So again, to write an exponential form, the base of the log becomes the base of the exponent. 64 switches sides, it's alone now. 3 switches sides and becomes the exponent on the base. And part C, the log of 7 with base 3 equals y. Okay, so 3, the base of the log, becomes the base of the exponent. Y switches sides, and 7 switches sides. So 3 to the y power equals 7 is the same thing as the log of 7 base 3 equals y. Okay, sometimes the log equation is more useful to us, and sometimes the exponential equation is more useful to us. So in these 3 examples, A and B are much more useful as exponential equations in terms of solving for the variable, whereas in C, if you wanted to solve for the variable, the log form is much more valuable. Example 2, write each equation in its equivalent log form. Part A, we have 12 squared equals x. Base of the exponent becomes the base of the log. X switches sides, and 2 switches sides. So 12 squared equals x is the same thing as the log of x with base 12 equals 2. B cubed equals 8. The base of the exponential b becomes the base of the log. 8 switches sides, and 3 switches sides. So the log of 8 base b equals 3. And part C, e to the y power equals 9. So this would be the log with base e of 9 equals y. And just like example 1, some of these are more valuable as exponentials and some as logs. So since logs can be thought of as exponents, it makes it possible to evaluate some logs simply by inspection. The value of the log of x with base b is the exponent to which b must be raised to get x. So in example 3, we have several problems that we want to evaluate. Example 3a, the log of 16 base 2. So to evaluate this, we want to think about what exponent do I have to put on 2 in order to get 16? Well, if I go through the powers of 2, 2 squared is 4, times another 2 cubed is 8, times 4 2's is 16. So since 2 to the 4th power is 16, the log of 16 base 2 equals 4. Question B, the log of 1 over 49 base 7 equals what? So again, we're thinking of 7 to what power equals 1 over 49? Well, I know that 7 squared equals 49, which is almost what we want. Okay, but we want 1 over 49. Well, there is a property of exponents that allows you to take a number and get its reciprocal. And that property has to do with negative exponents. If 7 squared equals 49, then 7 to the negative 2 power, negatives flip numbers for exponents. That would be 1 over 49. So the log of 1 over 49 base 7 is negative 2, since 7 to the negative 2 power is 1 over 49. Question C, evaluate the log of 5 base 25. So we are figuring out 25 to what power equals 5. Well, 25 is already bigger than 5. So if I square 25, I'm only going to get something bigger. So we have to think, what's the connection between 25 and 5? Well, I know if I take the square root of 25, I get 5. Okay? And in terms of exponents, there's one additional exponent rule that you have to remember. And that is that roots can be expressed as fractional exponents. The square root of 25 is the same thing as 25 to the 1/2 power. So the log of 5 base 25 evaluates to 1/2, since 25 to the 1/2 power equals 5.